Okay, here we are. We are starting Chapter 3. Chapter 3, displaying categorical data. And we'll start the timer there. And what we need to know about Chapter 3 that we really need to start with is the information from Chapter 2. And the information from Chapter 2 is that there are two types of data. There is categorical and there is quantitative. Categorical is also known as qualitative data. And with that, categorical data is data that is put into categories. So you're looking at things like eye color, you're looking at gender, you're looking at like maybe grade level, like 9th, 10th, 11th, and 12th. That is data that is put into categories, as opposed to quantitative data, which is data that is some form of measurement. And as you're talking about quantitative data, it's going to be numerical. But you have to be careful, because just because your results are numerical does not mean that your data is quantitative. For example, if we talk about like zip code or phone number, those are numbers, but those are categorical, because in order to be quantitative, you really have to be able to apply some sort of function to it, like find the average of it. And it's not like you're going to say, oh, you know, the average phone number for the class is this, or the average zip code for the area for the students is this. So because you're not going to apply that function to it, it is not going to be quantitative, so it is categorical. And this is all about categorical data. All right, so textbook says make a picture, make a picture, make a picture. Why does it do this? And this is going to happen a lot. Why does it say this? Because we're going to make graphs. Graphs are going to give us that picture of the data and the results. That's going to be very helpful for comparison purposes. Okay? All right. So what we're looking at here is a frequency table, and it's called a frequency table because what you have here is you have a variable and you have different categories of that variable, and you have counts or frequencies of that data. This data happens to be the data of where people were birthed, the B-E-R-T-H, on the Titanic. So that's what this represents, and it's frequency. And if we turn it into percentages of the whole, it becomes what's known as relative frequency, and that's a relative frequency table, okay? Fabulous. Look, it's a picture, and it's this boat, and look, it's a boat to represent the Titanic. Ah, it's a boat. And here's this boat, and here's this boat, here's this boat. And you know, there's something drastically wrong with this picture, and do you know what that is? And the answer is it's not the Titanic. And do you know why it's not the Titanic? And the answer is because it doesn't say Titanic on it. No, that's not why it's not the Titanic. Because it's not at the bottom of the sea. That's true, but that's not why this is not the Titanic. The reason is because there's not that little guy in the front going, I'm king of the world right there. No, that's not it either. It's because there's 3 smokestacks. Titanic had 4. Okay, so anyhow, what's wrong with this picture, besides me being stupid, is that if you take a look at this picture right here, here's a picture of the first class boat, and here's, it would be a picture, and it goes up to like 325, because there's 325 people there, and then here's second class, which is less, it was like 2 something something something, and it's less, and here's crew, which is like 885, and it goes this way, and you're like going, oh, look at that, it's so pretty, it's got this graph there, and it's got boats to represent the people, and the problem is this. This violates something called the area principle, and that's this slide right here, which is available on your slides. And here's how it works. Let's say that I use a square. Let's see if I can do this. Let's say that I use a square to represent the number of people on the Titanic. Okay, there it is. It's a perfect square, by the way, because I draw goodly. All right, so here's this square, and it represents the number of people on the Titanic. Let's say it represents the first class people. So there it is, total of the first class people, 325. And let's say that the crew is exactly double that. Okay, so in the crew there are 650 people. And so if I were going to take this square, what I'm going to do is I'm going to double the square so that it goes over to this scale of 650 there, and I extend it like that, and I go, look at that square. And you're like, what? But that's 2 squares. I'm like, no, that's a square. And you're like, no, that's a rectangle. You're right. Because if you think about this as you use the computer, if I click on the square and I start to drag it this way, I'm deforming it. It's not going to be that square shape anymore, it's deforming. If I wanted to extend it so that it's still a square, I have to grab it on the corner, click on the corner, and drag it this way. But when I drag it that way, what happens is that the square increases like that. And that's the square that's on a scale this way is 2 times as big, but realistically, because it expands in 2 dimensions, and believe it or not, we see in 2 dimensions. The square expands in 2 dimensions, and this square is actually 4 times as big. And when you look at this ship, if you look at my hand being about the size of that ship right there, this ship is not just 1, 2, 3 times as big, but it's 4, 5, 6, 7, 8, 9 times as big. And you see the area of the ship. And people will use this to distort this information. Because if, for example, not that someone would do this ever, but look, here's our cell phone picture that shows this is the amount of data that we cover, or this is the amount of area that we cover in the number of people that we have in our plans, and it's like blah, 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 up to X, and then cell phone company AT&X or whatever says, oh, but we have double as many people as T-Mobile X, and they say, look, here's our cell phone, and it goes over here to twice as big. But they're using a cell phone picture, and look, and it's like, oh, that. But the cell phone is 4 times as big, and you see this, and you're like, oh my goodness, it's so much more. Because it is, because this is not an accurate representation. Not that anyone would ever do that, because that would be wrong. Okay, so the area principle says that we see in 2 different directions. Okay, hey look, it's a bar graph, and here's what's really important. This is the data itself. There's the 325 first class people, and the 2 something second class people, and the 3rd class people, and the crew, and there's a bar graph, and we all know about bar graphs, and this is an okay bar graph, because, well, there's not a title here. There should be, but we have class listed here, and the categories, and the frequency. And important with the bar graph is that we need to recognize that with the bar graph, there is, let's see, oh, we've got 2 minutes left. There is gaps here. And the reason there's gaps is because these are distinctive categories. There are gaps in bar graphs, and bar graphs are for categorical data. And as we go to the next slide, this is an example of a pictogram, how we could do this. This, if we were going to do it the right way, what I would have would be a ship, another ship, and a part of a ship, which fits because the Titanic broke in half. So I'd have to have part of a ship here. So I'd create like a bar graph of the ships, which is what this is right here. I have, here's $1, here's like $1 and a half of $1, here's $3.1. That's how I could use pictures to do that. And you see this with the Olympics all the time, because they do medal counts. They're like, oh look, here's the U.S., and the U.S. has these medals like this, and here's China, and China has like these medals, and it's always this comparison, but that's like a half a medal. And then they sit there and say, oh yeah, and then here's oh, what's a really good country that, here's Antarctica. It's not a country, I know. There's Antarctica, and they've got 0. So, bad joke, all right. So, here's the pie chart. Oh, wait, let's go back. Okay, here is a relative frequency bar graph. It's the exact same thing as the bar graph, except for you've got relative frequency here, and we should have the words relative frequency here, because it's percentages. But notice that as you look at this, and as you look at the bar graph, that they are exactly the same. And they are always going to be exactly the same as each other, because the data between them is going to be the exact same data. Okay? Pie chart. We've done pie charts since we were in 1st grade, and here's a pie chart, and this is fabulous. This is not a great pie chart, though, because in order to be a really good pie chart, because these wedges are
based off of percent of the whole, what percent the crew was, and the size of this wedge is based off the percent, this data should be given in percent. That would give you a better interpretation of this, because the size of the wedge is made up of percent. And even though it says count here, that shouldn't. Pie charts in general should have percent. Oh, look, time's up. Okay, round 2 coming up.